Today, at this very moment, in cities throughout the United States, throughout the world, thousands of people are taking delivery of General Motors automobiles. No matter what car the new owner has chosen, no matter what model, no matter where he buys it, he can sense that his car represents a manufacturing excellence never surpassed in our industry. He can see it in the gleam of the finish. He can feel the solid construction, even in the thump of the door. He can see the careful attention to detail, quality fabric in the seats, inlaid effects on the door, long-wearing carpeting on the floors. He can see it through safety plate glass in all the windows. New car owners can sense all these things in Chevrolet, Pontiac, Oldsmobile, Buick, or Cadillac for a vitally important reason. This hallmark of quality that tells every GM car owner that this is a body by Fisher. This hallmark is easy to take for granted because for years, everyone inside and outside the corporation has come to expect a GM body to be good. But the people in Fisher Body don't take it for granted. They work at it. In all 33 Fisher plants, day after day, week after week, to make sure the bodies for General Motors cars live up to the name Body by Fisher. Every year, a new work cycle is begun when the board of directors meet to see the new styling proposals for the coming model year. The approval of the clay models sets in motion the vast activity of a huge organization. And this, gentlemen, is the story of that complicated undertaking, the story of people, the facilities, and the things required to bring a Fisher body up from clay. While the stylists are completing their drawings and models for the coming year, key Fisher body engineers pay them frequent visits to acquaint themselves with the renderings and the clay models and become familiar with the designs of car bodies they must soon manufacture by the thousands. In the highly competitive business of manufacturing automobiles, time can be a vital sales advantage. This early planning to shorten the time between styling and actual production sets the pace for constant effort throughout all Fisher body operations to cut lead time to the bone. The body engineer is sharply aware of the relationship between styling and sales success. But when he looks at a body idea, he sees more than classic lines and graceful curves. He sees a car body that, in addition to determining the appearance of the car, must also provide a great part of its structural strength. He sees the new body as an engineering challenge that literally must be constructed from the floor pan up of more than 4,500 parts. He must think of each of these parts in terms of the limitations of stamping presses and welders, of stresses that can be absorbed by steel and glass, and of such things as structural strength. And he must think of cost. The early discussions with the stylists give Fisher engineers sufficient information to begin preliminary body and die planning. Even before styling has prepared the styling drawing that will become the official go-ahead for Fisher body design engineering. There is much to be done before the styling drawing is ready to meet the exacting requirements of a body by Fisher. Back at the Fisher Body Engineering Building, acres of drawings must be made to solve problems of structural strength, clearances, hinging, weather stripping, and 1,000 other details that need not concern the stylist, but must concern the body engineer. For here at Fisher Body, safety, utility, and comfort must be engineered into the pencil lines and clay forms of the stylist, always with a weather eye on cost. Finally, after the more than 20,000 preliminary drawings required in an average model program, all the information is put together on dimensionally stable metal drawing plates, and the master body layouts are born. These layouts, with their lines so delicately precise they can hardly be photographed, become the Bible for the planning, testing, and manufacturing to follow. They are the Bible for the die engineers, already at work designing the dies that will form the steel into the new shapes. They are the Bible for the production engineers, who are designing the processes and equipment, the jigs and the fixtures needed to mass produce the new bodies. They are the Bible for the craftsmen in the wood shop, who are bringing the lines to life in wood. And they are the Bible for the craftsmen in the metal shop, who are making metal body parts by hand and assembling them into prototype bodies. Bodies for early internal showings by the car divisions, and bodies for endless testing. At first glance, the vast laboratory test facilities of Fisher Body seem to have been designed by some diabolical fiend, intent on destroying all the hard work of the engineers. Well, maybe there's some truth in that, because admittedly, the testing is planned to prove the engineer's designs. How does it operate at minus 20 degrees? Does dust penetrate the body seals? How about water? Will a passenger remain dry even in a cloudburst? Will the fabric stand 65,000 cycles of this kind of punishment? How much wear can the carpeting take? How much can the upholstery materials take? These and hundreds of other questions must be answered by Fisher Body test apparatus before production can begin. And as if the laboratory isn't enough, the test body, now mounted on a chassis, learns what it's like to dance over the Belgian blocks at the Milford Proving Ground. Here's a chance to find out in a few hard weeks how the body will stand up to years of hard driving. Is the body still structurally sound? Are its dimensions still within the original design limits? Do the hinges and locks still perform properly? Other Fisher Body Proving Ground tests measure shake and vibration, body noise, underbody water tightness, and that ultimate of all body tests, the rollover. At the same time, the test bodies are being torn, shaken, and smashed. The tremendous tooling operation is taking place. The die model makers are hard at work, handcrafting the shapes that will soon become hard die steel. Over 6,500 dies are needed for a typical model program, most of them designed and manufactured by Fisher Body. It takes 38 huge profiling machines working steadily to turn out the larger dies. The sensitive finger tracing the shape of the model, transforming its delicate motion into the cutting strength of the metal bit. It takes 95 other profiling machines to shape the hundreds of smaller dies required each year. And then comes the handwork, the craftsmanship so typical of Fisher Body operation. For it's the car body the car owner sees, touches, lives in, and he expects perfection, the kind of perfection that comes only from years of experience. While the dies are taking shape, other craftsmen are building the jigs and fixtures vital to the efficient, high-quality, low-cost mass production of Fisher Bodies. More than 2,000 side frames alone, a total of more than 36,000 jigs and fixtures of various sizes and shapes for manufacturing and for checking. They must all be carefully built and tested in pilot line operations before actual production can begin. The body design has been tested. Changes have been made. Tooling has been completed, and now production. 2.5 billion pounds of steel begins to arrive in the 9 Fisher Body stamping plants. Here, each graceful curve, first conceived in stylus clay, springs to life in a huge stamping press. Three 245 presses form the components of the Fisher Body. From a small 35-ton press to this giant 2,500-ton press that can shape 600 floor pans in a single hour. Fabrication, quality is constantly checked. Are the contours properly formed? Are there any wrinkles that indicate faulty steel? Is the floor pan ready for further fabrication? Welding is the next phase of fabrication. Automatic welding to form sub-assemblies such as the complete floor pan with its structural supports firmly in place. Each welding machine makes 90 to 100 welds, just a fraction of more than 5,500 welds required in the average Fisher body. And then another inspection to be sure the dimensions meet design specifications. Completed metal components are scientifically arranged on shipping dollies and readied for the journey by rail to one of Fisher's assembly plants. In the average year, Fisher Body ships more than 91,000 loaded freight cars, traveling nearly 55 million miles over the nation's railways. This tremendous volume of shipping has always presented the problem of parts damage. So Fisher has set up elaborate railway test facilities to help solve the problem. This unique railway, shortest in the world, never leaves Fisher Body Plant 40. Yet, because of it, components as well as completed bodies are now reaching their destinations undamaged. Specially designed equipment duplicates every freight car motion. Now, packaging engineers learn in minutes what formerly took as long as 6 months. As a result, this test device has paid for itself many times over by helping to reduce and eliminate costly in-transit damage to metal and glass. Meanwhile, in Fisher Body's cut and sew plants, nearly 40 million yards of cloth and coated fabrics required in an average year's production are transformed into seat coverings and headliners and door panels and all the other quality soft trim and upholstery that enhances the interior of a Fisher body. After cutting, the sewing begins. Perhaps nowhere else in Fisher Body is handwork more evident than in the cut and sew plant. It is the experience, the care, the craftsmanship of the individual that largely determines the high quality of the final product. Almost 400 different interior trim combinations are required by the 5 car divisions in an average year, each with the same Fisher attention to detail. One new method of fabricating interior trim utilizes machinery instead of handwork. Fisher process development engineers adapted the dielectric process to meet the public's new styling preferences. 19 giant presses use electricity to imprint decorative effects on materials or permanently weld two fabrics together with more versatility and at much lower cost than the formerly used sewing method. Door panels are finely trimmed on a merry-go-round line that combines the best talents of people and machinery. Completed soft trim from the cut and sew plants joins the metal components from the fabricating plants in the journey to one of Fisher Body's assembly plants or to one of BOP's plants. Again, in assembly, the emphasis must be on individual attention to detail. A quality body simply does not take shape automatically. Automatic devices move the floor pans down the production line, true, and jigs and fixtures are invaluable aids in precision assembly. But in the last analysis, human hands and human minds are the essentials of Fisher quality. Of course, the key to success of an assembly operation is scheduling, that complex and often unsung art that translates individual orders from buyers throughout the world into figures that guide the men who assemble each body. The maze of order forms, computers, teletypes, and telautographs ends here on the line in a coded notation that to the practiced eye reads, "This is a red and white hardtop Bill Brown ordered in Parsons, Kansas." All along the way, the body for Bill Brown's car is inspected. First, to make sure the windshield and backlight openings are dimensionally correct. Then, after soldering, after grinding, and after filing, it's checked again. Further filing corrects any imperfections these experienced men detect. And then, after another inspection, cleaning and rust-proofing, the bodies are ready for painting. In this special room in the Janesville assembly plant, the electrostatic painting process is being adapted to body finishing. Primer paint is applied by whirling discs, charged to 100,000 volts. Tiny charged particles of paint fly off the disc, seeking the nearest ground, the car body. This technique makes use of virtually 100% of the paint. After wet sanding and the first lacquer coat, the bodies are ready for their finish coats of acrylic lacquer. No practical machine has yet been devised to perform the random color selection required by the scheduling of more than 70 body styles with up to 450 color combinations. So once again, Manpower does the job, applying the more than 7.5 million gallons of lacquer Fisher uses each year. Then the freshly polished body is trimmed. Through this stage of an average production year, more than 2.5 billion pounds of steel have been used, 2.5 million pounds of aluminum, 1.75 million pounds of copper, 38 million pounds of lead and zinc alloys, 78 million pounds of rubber, and 213 million pounds of glass. And now, the final question must be asked. Do all these materials fit truly together? Is the body leak-proof? After the body's passed the leak test, soft interior trim is added. 100 million pounds of cotton fabrics each year, 10 million pounds of wool, 18 million square feet of leather, and 240 million pounds of miscellaneous materials. And then another inspection. Body, okay. Trim, okay. All that's left is final touch-up, cleanup, and polishing. And a body that each year begins as stylus clay is now reproduced by the hundreds, the thousands, yes, even the millions, as a quality body by Fisher. More than 53 million bodies and body component sets have been shipped from Fisher body plants to the various car divisions, nearly 4 million in a single year. And in every one of the car assembly plants and in the BOP plants, every body is scheduled to be dropped on its own chassis. Thus, it is that General Motors cars are born. Components for General Motors cars to be delivered outside the United States are packed in huge crates at the Bloomfield, New Jersey export plant, unassembled because of shipping rate advantages. 24 cases contain all the body and chassis parts for 24 GM automobiles, destined for assembly in General Motors plants overseas, after shipment from the nearby port of New York. At dockside, crated cars in huge stockpiles await loading aboard lighters to be taken to cargo vessels docked nearby. More than 2 million General Motors cars have begun their journey here at the docks of New York Harbor, headed for the 14 GM assembly plants outside the United States. In the past half hour, we have shown you a few of the 80,000 people who teamed together to produce Body by Fisher. We've shown you some of the 25 million square feet of our plants and offices. And we've shown you some of our more than $750 million worth of equipment. These facilities are constantly at work for General Motors in a never-ending cycle of planning, engineering, testing, production, to make sure the Fisher coach will always signify the timeless quality of the only automobile body known by name.